to the next presentation in track 2. This is by Mr. Cheng. Now, before we begin, allow me to first introduce Mr. Cheng. Ming leads Foundstone Consultants to provide strategic security consulting services to Global 2000 clients. With almost a decade of experience in business development, IT, and security, Ming brings extensive knowledge in both business and technology to his clients. Ming established the Asian Pacific branch in Singapore for Foundstone and has been instrumental in growing business for Foundstone in APAC. He has performed security assessments for security technologies, ISA server, firewall, and other security products, business applications, financial applications, CRM and tax software, and other technologies like multifunctional office equipment and IPTV. He contributed to 4 books and numerous articles published on Security Focus and other magazines. He is also a frequent speaker for conferences like CSI, MISTI, and others, including Hack in the Box. And he served as a lead instructor for Foundstone's Ultimate Hacking series classes. Ladies and gentlemen, Mr. Cheng will be presenting Triple Play, Triple Threats, IPTV security. Please join me in welcoming him.
In the presentation today, we'll talk about the agendas. The first thing we'll talk about the triple play strategy. That's how the IPTV plays for the telecom and also the business case. And the second thing is we'll talk a little bit about IPTV introduction, talk about the use cases, the architectures, and how it works. And then we'll talk about IPTV security. We'll talk about some things we have seen on the field work and heard about it or other things, and to show security problems. And then we'll talk about countermeasures, how if you are working for a telecom or any other related companies, what you can do in order to protect yourself or protect your customers. And then in the end, it's the conclusion. So just a little bit introduction of myself, and I'll skip this one since it's already done by Amy. And so before I start everything, just want to let everyone know that do not try this at home. Okay, so anything you get to know or you get to see from this presentation, just make sure that you have to be authorized in order to perform any kind of testing if you are going to do that at home. So first thing, let's talk about the IPTV market. Right now, the IPTV, the major component is part of the triple play. And what we call triple play is the data, voice, and also the video, all on the same network from the same telecom. Okay, and from the purpose of telecom to push this IPTV strategy is purely to increase the average revenue per unit. They want more money from you. Okay, so that's why they want to push more information, push more content to you in order to make business. And there are currently about 2 million IPTV subscribers worldwide. We're talking about Europe, Asia, and North America. And this is, of course, according to some marketing research. And so far, right now, out of this 2 million people, the Europe actually is the most mature market, and then lead by Asia, and the US is actually catching up too. And according to another marketing research company, iSupply, they're expecting 63 million subscribers in 2010. And that basically means the business is generating $2 billion dollars of revenue now, and is expecting for 26 billion in 2010. So this is something that telecom is using or building now in order to make money in the future and in order to compete with the local cable companies. And however, IPTV is not something just created yesterday, last night. It has been there since about 1995. Remember the web TV Microsoft was pushing? It's still there. It's MSN TV now. But that thing was just never get mature like today. Okay, so it takes about 10 years or maybe longer for the technology to go through different stages and finally adopted by telecoms and use that as a business case or as a way to make more revenue. So this is just a revenue graph for revenue forecast. In 2004, it's probably a little bit over $1 billion. And then in 2005, 2006, right now, in 2006 is about $2 billion total. And as you can see, Europe is making the most money, and APAC, even though there might be more subscribers like PCCW, actually they are one of the largest IPTV provider in the world. And so they are expecting the revenue is growing more and more in the next couple of years. So now let's talk about there are different forms of IPTV services. The first form is part of the triple play strategy. We're talking about this as from the telecom's perspective. Like you are a local telecom, you already provide phone services, you already provide data services like internet ISP, and now you want to provide the content of video. So the good thing about using telecom's own network is it's very easy to control quality. Okay, if you ever try to watch TV through any type of streaming protocols over the internet, the only thing you will worry about is really the quality, the performance. And if you are doing that as a business, part of the business for the telecom can actually control the quality of service on their own network in order to give you more bandwidth to enjoy the normal definition or even high definition TV content in the future. The second type is a standalone service provider. So they pretty much like probably sell you a set-top box, and you can go home, install the set-top box, connect to your television, and using the internet as their own backbone. And you pretty much you can watch TV content from China, and while you are sitting somewhere in London or any other places on Earth. Okay, so that's a standalone service provider. They are not depending on any telecom. They are not depending on any other companies. And technology used that other than the standard web TV we have seen or the real-time streaming protocol, we have also seen new things like peer-to-peer streaming. Okay, so that's kind of program people wrote from China, and not talking about whether it's legal or not for the content, but they are using peer-to-peer streaming in order to streaming TV content to everywhere around the world. The quality is not that good because basically all the traffic goes through the internet, and there's no control. No one have the control for the internet to guarantee the quality. And there are others, short videos, small videos like with lower resolutions like YouTube, Google Video, other video bloggers, or like Microsoft right now. Recently they have the MSN video services. Those are the others, but most of the time those videos are not with good quality for you to play on the TV. And according to the marketing research group, there are actually over 350 IPTV service providers worldwide right now. It's kind of surprising to hear that number, but I guess if you look at it from like 10 years down the road, then there are a lot of standalone service providers in different regions. And also there are 60 different vendors. They are providing either hardware, software, middleware, and all kind of product from set-top boxes to different encoding servers, streaming server, and all that. And today our discussion will actually focus on the first type of IPTV, which is part of the triple play strategy by the telecom. But I just wanted to give you a high-level overview of what other things there are or other possibilities there are. So for telecom, there are, they already have the phone service, they have the data services, so there are a lot of known security problems. For the data services, home computers were being turned into zombies and use that for phishing, spamming, or even the denial of service attack agents. So those are the things that people already know. And voice over IP, okay, so we'll have the Grok talk about this tomorrow. But basically, in summary, voice over IP is the second, actually, the telecom has the voice over landline in the beginning, and now they're also moving to voice over IP to save more money. And the problem with voice over IP, of course, you have conversation eavesdropping, you have phreaking, or how we call like making free phone calls, and device insecurity, denial of service problem, and so on. Tomorrow you can go to the Grok's presentation and you can learn more about VoIP security. But these two items are part of the triple play strategy, and they have their known securities already. And we just want to look at, once the telecom introduce IPTV, what kind of other new security problems they are going to introduce too. So the next slide, we will talk, give a high-level overview of IPTV. So in a simple word, basically IPTV provide video contents over it on your broadband network. Okay, so there are normal subscriptions like your daily channel, you watch BBC, you watch CNN and all that content, you get that on IPTV service. And there are video on demand, where whenever you want to buy something or you want to watch some movies, you can actually purchase that on the fly and watch it for a 24-hour period or however the telecom is going to charge you. And then there could be interactive applications. For example, you might have web browsing, that's pretty basic, email, online games, and others. There are so many different services in Asia Pac service providers, like they could provide karaoke or even like online ATM, things like that. So in the future, I think there will be more security problems once people begin to introduce more and more new interactive applications. And basically, we will see more new stuff. But today, we will be more focusing on the subscription part and video on demand part. The architecture part, we will look at IPTV, and I basically split the IPTV into three components. The first one is content source, the second part is delivery and management network, and then the third part is home network. Okay, so we kind of want to walk through the IPTV as a home user. So a user probably don't feel the difference between the technology you're using. Either it's a cable modem or it's using the ADSL with IPTV. It doesn't matter too much. So we kind of like walk through and basically to understand the user experience. First of all, if there is something called home gateway, boots up and authenticates to the server. This architecture is not being used by every vendor. So some of the telecoms, they are starting an initiative called Home Gateway Initiative. You can go to that organization, www.homegatewayinitiative.org. That organization, they are trying to create an architecture where every home has something called Home Gateway, which has the functionality of wireless router, broadband sharing, and also providing a multicast proxy and all those necessary functionality for home entertainment. So think about it like a gateway between the telecom and also your home devices. So if there is such device, then you basically boot up and authenticate. If not, then basically it's the same, your setup box is actually behind the DSL modem. And then you boot up the setup box, which before you turn on the TV. Usually the setup box will use DHCP to acquire IP addresses, and using either TFTP, trivial FTP, or network file system to get the configuration file or the latest boot images. So the telecom can perform like centralized control or centralized management. And then either the setup box would authenticate with MAC address, which we've seen quite a lot, or random nonce, or something like involve public key and private key if the service provider implemented like digital rights management. So after the setup box successfully authenticates itself to the network, basically it's being authorized to watch TV or purchase video on demand. It will begin to you can begin to choose and watch your channel. Most of the channel content is broadcast or multicasted by IP. So there are two different types. One is unicast and one is multicast. Most of the time, well, basically it's using multicast, and unicast was only being used when you are changing channel. Okay, well, actually it depends on the vendor implementation. So there are vendors, they implement unicast. So when you change channel very fast, like your channel switching, and it will use unicast to broadcast, to send the content to you, so to reduce the delay. And in order to normally join a channel or leave a channel, pretty much basically every channel in that service provider has an IGMP network address and port number. So when you need to watch a certain channel, BBC or CNN, you just need to join IGMP multicast group. And when you want to leave, you just pretty much need to issue IGMP leave group command. And also in that case, when you are after you finish watching your TV or you feel like watching a movie, you can go purchase your video on demand by just choose and purchase. There are other functionalities, for example, like parental controls or small things like that. But pretty much this is the experience you're going to go through if you are a home user. And of course, if there are other interactive applications like karaoke or something like that, then you can definitely use that. So we talked about IPTV architecture in the overview, and I basically put them into 3 different sections. As I mentioned earlier, the first one is content source, and then the second part is management delivery network and home network. We'll go into each sections later in more details, but pretty much this is split according to the functionality, and it's probably different than the vendor brochure you will find on the internet. So I just want to let you know that. And most of the attack we found will be targeting the home network and also the management and delivery network. Okay, the content source, they are usually pretty separated from what normal customer will see, but it doesn't mean there's no security vulnerabilities, and we'll talk about that later too. So the first component is content source, and basically that pretty much means all devices, processes, and networks that import and store video contents or broadcasting normal TV programmings. Those content come from different sources. It could be satellite, radio frequency, or the pre-recorded tapes, or either from cable modem or other type of sources. So the content source pretty much import all the content from different sources and then store into different servers with directories, with file servers to manage to get ready to deliver to the client. So basically that's what content source is for. And delivery and management network pretty much is all devices and the network used to deliver the video, and they deliver the video through the network to different customers. Okay, so that includes encoding and streaming servers. So basically change the content into multicastable data packets, or just performing encoding for that. Video on demand servers, accepting user orders and then returning proper content to the user and performing authorization, authentication. And also the network backbones. All the infrastructure, either you use VDSL, very high speed DSL, or video DSL, I'm sorry. Or other different type of architecture and different network devices and so on. Okay, so their major functionalities is what we were talking about: customer authentication, authorization, and customer service. And also, they provide video content, either the normal or on demand, through multicast and unicast, as we talked about earlier. The home network, usually we call the device or the equipment at user's home, we call them like customer premise equipment, or CPE. And that's basically anything that connects to a consumer's home network or inside this home network. We're talking about the computer you own, we're talking about a set-top box you own, and the home gateway if you use one, the game console in the future, your phone, and anything else in the future. So that's pretty much the cover or the scope of the home network. Okay, so the next thing we want to talk about is basically the attacker scope. So think about that. After you look at the architecture, you look at the content. If you want to attack a telecom, what will be your goal? So we pretty much think the goal will be 2 of them. The first one is try to take control of a large amount of home networks as much as possible. And what you can do, you can perform service disruption. You can spreading worms, trojans, virus, and you can broadcast your own material for either political motivation or whatever purpose you have. So that could be one potential goal that the attacker could have. And the second thing is more simple. Basically, you just want the content. You just want free TV, you just want free movie, and or someone wants to rip up the content as simple as being a peer-to-peer TV source, sort of things like that. So That's kind of the two potential goals. Of course, some people, they may also want to take over the telecom infrastructure, trying to get to every user's account and things like that. Potentially, that's another like internal internal threats and that type of thing. So. And the next section we'll talk about is some of the known security problem we have seen on different components, including home network, delivery, and the management network, and also the content source. So the first thing is for the home network. When people want to try to test the home network, the major thing you want to understand is how does the authentication and authorization are done. Okay, it could be as easy as spoofing a MAC address. That's actually some of the cases we have seen that people only use MAC address to perform authentication or authorization. And it could be as complicated as using like AL2.1x to do EAP control, and if you are not on the customer list, you are not going to get on the network, you won't be able to watch the TV at all. So it could get very simple, it could get very complicated. The point here will be that for different service provider, they will actually do different things. So what you have seen here may not work for every telecoms. And there are a lot of security vulnerabilities on home network devices, including how the device is managed, how the device, if there is any other vulnerabilities on the devices. So as we mentioned earlier, we want to know more about the authentication and authorization. So here is a typical setup box communication with the servers. Of course, the first thing, they download the boot image from the TFTP server. TFTP doesn't have any authentication. It's not, no authentication is required. That pretty much means if a setup box can download the file, you can download the file. Okay, so you pretty much get the same thing that a setup box could get. And then setup box could register itself to a middleware server. In IPTV infrastructure, you will see a lot of people using middleware server, and those middleware are taking user requests and authorize them to see if they are authorized to watch the video on demand or if they can do something else. And then setup box will receive a channel listing, application directories if there's something other than just videos. Okay, so that's what setup box will see. And then setup box will issue an IGMP membership report. And some of the vendors, they might use IGMP version 3, some of them might use version 2, and to indicate the current channel or if they want to join a new channel. Leave group. If you want to join a new channel, first you have to leave the current channel using the IGMP leave group message and to leave the channel. And also, sometimes for some of the setup box, they will actually send out a power off packet. Okay, so the setup box is actually not completely power off. It's kind of into a standby mode or kind of like sleeping mode, and it could be wake up pretty easily, so to boot up faster. Device management problem. A lot of the devices, they are still being managed by SNMP and Telnet. Okay, so whenever you found, sometimes it's just on a different port. You have seen all different advisories against different devices where there are management interface running on port, say 27,000 or something like that. You know, so for different setup boxes, there are different ways to manage them too. For example, using Telnet, some of the setup box, they actually have Telnet either running on the standard port 23 or on a non-standard port. And the point is, most of the time when you Telnet into a setup box, you are root directly because most people doesn't bother to secure the Telnet management interface too much. So one of the example we were able to find is once you Telnet to the setup box and then you know the port by scanning the setup box, of course, you automatically get like kind of like a prompt, and you can actually perform like leave M group as leaving this current multicast group, and then you can join M group, for example, if you want to have your neighbor watching the Playboy channel while they are while they are not aware of that. So you can do that and perform this just to have the other setup box join a different group, which means changing a channel. And information transmitted in the clear. So we mentioned earlier that setup box has a lot of information. For example, PIN number for parental control or VOD purchase, We have found cases where the PIN number is actually not protected, not encrypted. All the traffic is running on the clear text, and you can even change that on the fly. So people could just post it on the online forum and telling teenagers how do you bypass the parental control of certain vendors' IPTV product. Things like that could happen. And another thing is account number. So the good thing is we never found anyone basically passing like sensitive information like social security number or people's name, anything like that. It's pretty much represented by account number or using a MAC address authenticated with a backend database. So that kind of reduced the concern regarding to privacy. And local access to device. Once you get a set-top box, pretty much you own it, right? You can do anything with it, and as long as you don't care about the acceptable usage policy, you can do whatever you want. So one thing people could do is basically just simply plug in a USB keyboard or mouse. That's what you do to any device that has a USB hole there. And some of the set-top boxes, you can actually get command shell access on Windows-based set-top boxes. This is not Telnet. So Telnet, you have to do it through the network, right? And this is totally like a local access to the device. And how you usually do that is kind of like kiosk security, where you plug in the keyboard and the mouse, and then you basically, the first thing you want to get is like a program like Internet Explorer or any type of thing that would browse to the internet and have the access to the local file system. And then you can basically press like F1 for help and or some different key sequences where you can call another place, where you can call like multimedia player or something with a file menu. And then at that point you can put in like file column / to get access to local system. So we have done that, and we have seen one of the set-top boxes. Actually, there are tools on the set-top boxes where you can modify the content of the EEPROM. And as we mentioned earlier, if your set-top box, if your IPTV authentication is based on MAC address of set-top box, at that case you will be able to change the MAC address on that set-top box, and you can become whoever you are. Think about that. Most of the providers, they have the set-top box manufactured by one single vendor, which means the MAC address are pretty much fixed, right? So all you need to do is just kind of go through the sequence and try to guess other people, and you can get some subscription for free. And it could be you might have access to other information, for example, like DRM related private key or public key or anything like that. Okay, so that's also possible that if you are able to locally compromise the DRM, compromise the set-top box, because if the vendor is going to implement DRM, some of the information will be stored on the set-top box, and once you recover that information, there's an opportunity you can break the DRM. And with a TCP/IP stack, so we found that basically, most of the set-top boxes, they have limited memories and resources to use. So when you are watching TV, actually the set-top box, certain type of set-top box, they will open a service listening on some high port running UDP just to listen to the multicast traffic. And at that point, you can pretty much, you can use iSIG to do the test. Pretty much use the UDP SIG, which will generate random UDP packets to test the stack integrity. And for some set-top boxes, this is going to be denial of service. The set-top box could be killed and then automatically reboot, and it may not even come back in some cases. It could be a useful case if you want to perform a denial of service on a large home network of certain telecom. For example, you take control of most of the computers on the home network for the customers, and then you install a malicious program and launch the denial of service attack at certain time automatically and to reach the effect. So this is one of the problems that could happen, for people to utilize that. There are other vulnerabilities, for example, web management interface, data validation problem. We have seen problems like file system traversal problem on different devices, either set-top box or others, whatever uses web management interface. And the thing is, by using that file system traversal, you can get on the device and get different files and for different cases. In a lot of cases, we actually are able to find like unencrypted password or simply certificate for authentication, things like that. Just because people didn't really protect the data on those devices. And of course, you can always try other standard web application assessment against those web management interface, and you will have different findings. There are also weak and default account and passwords. It could apply for web management interface. It could apply for telnet, secure shell, or just simply SNMP. Okay, so a lot of service providers, they still use just plain public and private to manage all devices. The next section we'll talk about is delivery and management network. So for the delivery and management network, usually there are hundreds of servers on that network. It includes both IPTV and potentially non-IPTV, the old telecom servers. And the access to other servers is the major point of attack. You can see middleware servers, you can see streaming encoding server problems, and potentially you can also access to other servers. So to access the other servers is pretty easy. All you need to do is just change your IP address to the network, to set-top box's IP address range that you are on. Okay, different service provider will use different IP addresses network, and you just need to sniff the network and figure out what's the IP address range they're using, and then you can get on. And then the next thing usually you will do is scan the network range, and you can find middleware server, database server, and different other servers. What can you usually find? Basically, for example, we have found passwords in spreadsheet or password in configuration files where you can get through directory browsing. Okay, so a lot of people, they don't protect the internal servers because they consider this is a closed network. It's owned by the telecom itself, so they may not put as much security controls as internet-facing server. We have found web manager interface for middleware server or database servers, and the web manager interface for like Oracle database connections where it's controlled with the customer data and all that. And also we even found like movies for test, right? So you can find some people, they will leave DVD files on some servers for IPTV testing, and they are not protected, and you can find that. So you can find a lot of things on the management servers, and it really depends on how careful or how security aware the telecom is. Okay, so the next thing we want to talk about is the streaming and encoding server. We'll talk about two things. One is the RTSP buffer overflow, and then the next thing is we'll talk about the weak TCP/IP stack. So the first thing is real-time streaming protocol. It's actually a request. It's actually Internet RFC standard. You can check out the www.rtsp.org to see the detail. Most of the time, you will see it being used when someone wants to purchase video on demand. For example, the first content. There are 4 different methods being used: describe, set up, play, and get parameter. RTSP basically is a protocol similar to HTTP. It's an ASCII-based protocol where everything is human-readable format. There's nothing like an XML tag or binary protocol, nothing like that. So one of the problems you could find is look at this describe request. Basically, you have the describe, and then you have the RTSP column / VOD server, whatever that IP address is. Usually, RTSP service is running on port 554, and usually you can access to a certain provider's asset. The asset here basically is a video for being purchased by video on demand, and this is kind of a simple request you're doing. And you can either change the URI for the describe methods to get a large chunk of data, and then you pretty much get a buffer overflow on the video on demand server. Okay, So other location of the implementation might have the same problem where you can change the method or change the URI or change other places, and you can still reach your buffer overflow result. The result for buffer overflow is pretty much either a denial of service attack or you get control of the VOD server. And once you get control on the VOD server, you pretty much have your own IPTV service, and you can just purchase whatever video you want, potentially free, I guess. Yeah. So in order to test that, there is something called Protos, and potentially you can come up with a set of programs to do Protos for RTSP protocol. Just look at the ABNF protocol form of the RTSP protocol, and then generate different test cases, and using the Protos tools to do that. Another thing is a weak TCP/IP stack. So what we found on the set-top box actually also exists on the streaming and encoding servers. It's kind of a well-known thing that for some reason no one really fixed that. So some of the streaming or encoding servers, they are good at sending data because they are designed to do that. They are handling millions of customers at the same time. That's how they are designed to do. However, they are not good at handling incoming traffic. Okay, so potentially an MMAP full-port scan could degrade the server response from 10 milliseconds to 3,000 milliseconds, for example. Okay, so that's kind of something happens in the real implementation, and if you make the scan more aggressively, or do other scan, sometimes it could cause a denial of service situation where you could have killed the encoding or the streaming server. Most of the time, the encoding or the streaming server are only responsible for the normal TV programming multicast. They are different than the video on-demand servers. Okay, but they pretty much most of the streaming and encoding servers would have the weak TCP/IP stack problem. Okay, so the last component we'll talk about for security problems is finding the backup and finding the source and the VOD manager thing. So what happens if content source? The goal for people to attack that is pretty much you want to steal the source directly, bypassing home network, bypassing delivery and management network, and that's one of the goals you do, right? So remember last year, it was a laptop stealing year. You hear about the news like, people stealing laptop or people stealing backup tabs. Almost every bank or a lot of major companies, they suffered some loss last year by being stolen, by the backup tapes or laptops being stolen. So those could be a way for people to do that, to attack the telecom. And the other way is finding the source. For example, tomorrow there will be a talk about how do you hijack a satellite connection. It's not totally about IPTV, but it's definitely, since satellite is one of the sources that IPTV could rely on the content source, so it's definitely an interesting talk that you should check it out. And Video On Demand Manager. In some of the cases, you will be able to find a web management interface or potentially more on the network a set-top box could reach, which could manage the video-on-demand files from the content source. Okay, so earlier we were talking about creating buffer overflow problems on the video-on-demand servers, and now if we are able to go to the source, go to where the video-on-demand is being managed, then it will make it easier. So those are the problems on the content source. We'll kind of like, after we talk about the security problems, technically, we will talk about how those security problems could related to privacy, confidentiality, integrity, availability, or interoperability as a summary. So the privacy part, basically people care about how telecom handle the customer information. A few months ago, probably people heard about that, like AT&T AT&T has a policy pretty much like they own the customer information. So that's become a debate in the US. So privacy is an important thing that people will care. So far the good thing is when you are using IPTV, you are not transferring anything more than just like, for example, the PIN number you set up or the account number you have with a telecom. Okay, pretty much nothing more would be sending out from your set-top box. But there could be potentially vulnerability on the back-end billing system if you spend enough time to dig into the network. And in that case, what people can find will be more like the whole database of the telecom and with everyone's account and names and billing information. Okay, so in that case, there will be a big privacy breach. And also, there could be argument regarding to how telecom manage the CPEs, the customer premise equipment. Do they own that, or does the customer own that? The access usage acceptable usage policy. How do they set up, and how does the user want to do that? So those could be the concern when IPTV vendors are trying to provide a service or push the service. People might have concern adopting that. And of course, there could be legal involvement when the telecoms are trying to sell the services in either the US or other regions. Confidentiality for video content. So not all of the telecom will implement digital rights management. It really depends on how much they want to do or how they want to, how they treat the content, whether they want to protect to the extreme or they are okay just leave it open when they just need to take care of the part from the video server to the home network. Okay, and remember there is always the analog hole problems right now, where from your set-top box to the TV, right now most of the signals are still unencrypted. Before, so you can still steal the content through that, and the people are trying to develop HDMI standard to address these issues. So in the future, if you buy a TV, it might support HDMI, and the HDMI will actually try to encrypt the content between the set-top box to the TV. So if you want to try to steal that content, it will just be harder. But as we mentioned earlier, when you get onto the IPTV, you own the set-top box. You can pretty much do a lot of different things to the set-top boxes. And for Windows Media Windows Right Management, people are writing programs to strip the DRM out of the content. So things like that could happen in the future when the IPTV service is more widespread and people feel the need to rip off the content. Okay, and also we mentioned about all the backup tapes, laptops losses in 2005. There are really a lot of people stealing information through that way. And for newer set-top boxes, they can also act as a digital video recording. And so, how the data is being protected and how the data can be how do you expire movie content on the set-top box in 24 hours? Right, so those are the problems. The key has to store somewhere, either on the server side where the client has to access to that every time they want to watch it, or it's stored locally on the set-top box. So it really depends on how people implement that. Authentication and authorization. As we mentioned earlier, it could be as easy or as simple as sending out a MAC address, but it could be as complicated as a combination with AO2.1x and or DRM public key, private key authentication. So it really is depending on vendor to vendor. And other interactive applications, as we mentioned, in the future, more and more people will introduce interactive application, either online gaming, either more interactive online ATM or things like that. So those things will have their own individual security problem, and you will probably see the set-top box growing to be a home entertainment hub or entertainment center, and then it pretty much will probably grow back to like a normal computer. Integrity, basically we're looking at how can you modify the content while for the telecom. For example, multicast and unicast securities. There are some security issues regarding to multicast and unicast itself, either on the device side or the protocol side. And so far, I don't think it's a very, very serious problem yet. And in the future, if the service is more widespread, it might become a more important issue. And also content source security. So when people get onto the video on-demand manager, can people change the content before they replay that, or can they modify the content on the fly? So those are the things people will care about. Billing system integrity, we'll talk about the billing system, we talk about internal threats. So potentially internal threats is definitely something people will have to worry about. We have heard about telecoms insiders selling data, customer data to third party for profit, right? So it happens and it's a problem, and introducing new technology does not help that. Other system on the network, we have seen telecoms with very good protection on all the system on the network. We also have seen very poor protections on the network. So there are different telecom will do different things, and it's very important, to secure the other system on the network, because sometimes you never know which machine is your weakest link to get to other machines. Availability, we mentioned a lot of ways that you can try to disrupt the IPTV service, either by killing a set-top box, killing a video-on-demand server, or streaming or encoding server. And so it just depending on to what scale does people want to disrupt the service. Okay, and we mentioned buffer overflow and the weak TCP/IP stack that you can do denial of service attack. And how about dependencies, voice and data? Right now it's kind of separated, but actually it's not totally separated. You're using the same backbone as the other two services, the voice and the data. So they are doing control through quality of service control and other management on the ATM devices or the different devices on the backbone. Okay, so if the backbone is down, that will take down the service, and it depends on how people handle about the availability issue. Interoperability, there is currently no common standard on IPTV other than multicast and unicast. Everything else is pretty much depends on the vendor, which could be good and bad. The good part is, one vulnerability you identify on one service provider will not work for another, so I assume that's probably good. However, it doesn't mean that you can, hide from people looking for security vulnerabilities. So there could be a good thing and a bad thing both on the interoperability. There are standards on the work. For example, ITUT, who is the organization making ISO standard, there is IPTV work group, and they are actually working pretty hard this year to try to make some standard work. They actually have their next meeting in October in South Korea. There's another organization called ISMA.TV, which is their website. They already published like a DRM standard they wish some vendors to use, and I think their CTO is working for Apple Computer, having the thing on the QuickTime. So there are ITU, ISMA.TV, and a few other organizations trying to push and to create an IPTV standard for the industry. As we mentioned earlier, the standard is more for a telecom who is running IPTV on their own network. Okay, so the next section we'll talk about the countermeasures. We'll talk about how a telecom could protect themselves, what kind of things they might want to consider to do regarding to organization, policies, procedures, and technology they are going to use. So organization-wise, basically you pretty much need to have a security from the beginning. Most of the telecoms have their internal security team already, and so when you add a new service, you pretty much just need new people who know or who understand the technology and able to contribute and work with existing security teams to define all the information. So you need integration with current security teams, and you make sure those security teams are responsible for security program management and from planning to deployment and also incident response. IPTV is a new thing. Probably not many people knows about what constitutes as IPTV fraud. Okay, so it's probably a little bit hard to do the correlation or to do event management at this point. However, those are the things that a security team needs to do. And secure development lifecycle. So most of the telecom, they are not going to develop their own in-house solution for IPTV. They will rely on external vendors' product, existing product, customize them, and use them in the on the field. So it's very important for the security team to evaluate, test, and response for the technology they are going to use to provide their service. And gap analysis is important for them to understand, before you adopt IPTV service and after you adopt IPTV services, how has your security been either improved or staying at the same place, or it's getting worse. Okay, so you need to, the team basically needs to understand the security baseline at the beginning and keep tracking of that, update the status as new technology are involved. So the next one is program and procedures. Basically, one thing we identify is that a lot of the vulnerabilities, if the telecom could control the access control list very well, then you can pretty much mitigate or eliminate a lot of problems. For example, if I want to control my neighbor's set-top box, and basically the telecom could pretty much set an access control list on the router that I would be talking to, and to forbid any traffic going from another set-top box, or one set-top box to another set-top box. So pretty much you can try to prevent that by setting up a good ACL. And it's very important for the change management procedure, because a lot of times we are looking at thousands of router rules, switch rules, that people will get confused and no one knows what this rule is for, and it could accidentally be taken off, and people would have the opportunity to go back to utilize the security problem. And then you need an incident response program. Basically, you need to make sure you are able to recognize any problem. For example, your service is down, you need to be able to know the problem, and you need to be able to respond to find out what's the problem. And you need to learn the lesson from the problem and evolve your architecture or your product, your technology from in the future. Okay, and security evaluation program and procedure. For whatever technology you are going to use, pretty much you have to evaluate the security in technology and also deployment. You look for best practice. You look for whether the product has been tested for things we mentioned about, like buffer overflows, like file system traversal, different type of security problems before you buy them or adopt them. Technology, when you want to use a product, of course, you want to make sure that it's a secured product. You will look at the vendors if they have secured SDLC, if they perform security evaluation before they sell you the product. And you want to look for deployment best practices and see if the vendor understands where your environment will be and what's their recommendation for you to secure your environment. Major security impact to performance. Security is a trade-off, so you want more performance, and sometimes you might not be able to make it as secure as possible. Sometimes DRM could cause performance impact. You might have to have 1,000 servers instead of 600 servers to handle the same traffic. It's always a trade-off, and if you work for telecom, you definitely have to do the trade-off according to your measurement and compare to the performance. Monitor and management. Basically, if you want to do incident response, you want to do fraud detection, you have to be able to monitor the whole traffic and manage all the events. So how do you recognize IPTV fraud, for example? And bring security into standards. Okay, it will be good. We've been seeing, if you go to ITU website, especially the IPTV work group sub website, you will see a lot of input documentations from different companies. They are already contributing to the work group regarding to putting security into the standards. Most of the concern right now they have still protecting the content, which means DRM. And as Bruce Snyder said earlier this morning, that's a technology protecting the user against the user. Well, it's not protecting the user, but it's against the user. It's protecting the content against the user. Those ITU, those organizations, they need to understand this, some of the security issues, not just only the DRM. Conclusion. Basically, IPTV has been adopted as one of the triple play strategy, as we mentioned earlier. Okay, so in the future, it's going to be evolved into multiplay. The multiplay will involve more like mobile phone television, more interactive application, online games, online ATM and different applications, and that's how people are calling that multiplay. I think HP is trying to sell a lot of interactive multimedia management system to the telecoms moving toward this multiplay. So when you're talking about more technologies, there are more issues about deployment, about best practice, about securing the whole system, and then it's easier to create a mistake when you have thousands of things to care. And yeah, so that's pretty much the trend. Excuse me. And the risk still exists because there are vulnerabilities in technology, as we mentioned. Buffer overflows, file system traversal, weak TCP/IP stack. Those are the vulnerabilities in technology. And we also have weakness in deployment. When people deploy the architecture or the whole IPTV service infrastructure, they did not secure the whole infrastructure. They did not change the default password. They did not protect the service or the device well. And the last thing is incomplete or insecure processes. So basically, after you deploy that, you don't have a good change management rule or the change management procedure. So you might accidentally take off a router rule or a firewall rule and letting people getting into your network. Okay. The countermeasures we talked about earlier, you have to do it through organization, process, procedures, secure deployment, choosing the secure technology, and so on, in order to mitigate technology risk and make sure you create a security awareness in your organization to let people know. Okay, so that's pretty much the presentation for today. There are 5 minutes left, so we will open, or actually, it's not. We're open for any question or answer. If not, then thank you very much for the conference and everyone here.